I wanted to take a few minutes here and discuss with you about predicting with the normal distribution. I know that many of you are either puzzled or frustrated when you look at a set of data and you say, well, it says that 20% will be greater than this amount, or 40% will be between these two values, and actually it's way off. I want to see if I can explain that to you, because I think it's a great question to ask, but it's an even more interesting answer to the question. When you're predicting using the normal distribution or z-scores or a calculator based on the normal distribution formula, you are making a very important assumption. You say, well, I've got the mean, I've got the standard deviation, but that doesn't mean that your distribution is normal or even approximately normal. I put a group of data here together. Let's say we've got 3 sets of data for distances commuted to work. I'm going to call them just drive A, drive B, and drive C. We went out and we collected a sample of 35 from 3 different sets of commuters. And when looking at the data, we calculated the mean, the standard deviation, the median, and found the modes. And looking at drive A, drive B, and drive C, all of the means are pretty close together. The medians are exactly the same. Now, they all seem to be bimodal or have 2 modes. You see these 2 here, pretty spread apart. These are higher. These are very close together. Then look at the standard deviations. The standard deviation of drive A is almost 15. For B, it's 9. And for C, it's just 4. Remember that the standard deviation measures the spread of your data. Now, let's take a closer look at each of these. It looks like for drive A, I've got a lot of values down, in the lower ranges. I just made a little frequency distribution here. For drive B, I've got a lot in the 30 to 39 range, quite a few in here, and none beyond the 30 to 39 range. Whereas in A, I've got some values way out there. For C, it looks like my values are mainly in the 20 to 29, with a few in 10 to 19 and a few in 30 to 39. So you can see the data is definitely different, but as noted before, the means are all very close together. Now let's look at a histogram for each. Hopefully, you will see that it looks like for drive A, you could almost say that it's right-tailed. It's tailing off. If I drew a distribution way off, it's an interesting shape. Drive B is definitely left-tailed. It hits a wall right here, and everything's to the left. Drive C, it's kind of boring, but it looks pretty normal, or like a bell-shaped curve. Now, when you use the normal distribution to predict what percentage or what is the probability that you are less than a value, greater than a value, or between 2 values, you're only using the mean and the standard deviation and the sample size in some cases. But, with our calculator, we just put in the mean and the standard deviation. You didn't even tell the formula your distribution was skewed to the left or skewed to the right. You can't. The formula assumes the data was normally distributed. Therefore, when you get strange actual percentages of data, a lot higher or a lot lower, versus what the normal distribution predicts, this very well could be a major cause. Let's look at drive A. I've tried to overlay a normal distribution on top of this histogram to let you see this is what the normal distribution thinks the distribution looks like. And it's not necessarily normal. It is skewed off to here, so you can see how your prediction would be off. What about for drive B? For drive B, notice this is what the distribution thinks it would look like, and if you were trying to predict something out in here, say actual versus predicted, you would be way off, okay? Or something out here, you know, you could be off. Over here, you'd probably be in good shape. In here, you would be way off because, you know, actual is right in here, and it thinks that that's the highest place. For drive C, I pulled it in because the standard deviation was so much smaller. It's much, much better, but still, you know, it's not perfect. But it is a much better fit as far as, you know, being able to predict things. You would probably be pretty close here. But don't say that predicting using the normal distribution doesn't work. It does when applied to the right situation. However, nothing is ever going to be perfect. Are there ways to predict highly skewed distributions like we've seen in these couple of cases? Absolutely, there are ways to predict those, but that's for another day and for another course. I just thought these were some questions that you might have, and my explanations might help you in understanding those.